Bismillah ar-Rahman ar-Rahim. I am Bushra Al-Muhammad. I'll talk about dental amalgams. Our reference is Richard Minort from page 61 to 71. Amalgam is used to restore the lost tooth structure in class 1, 2, 5, and complex restorations. Amalgam is an alloy of mercury and one or more other metals. It is produced by mixing mercury with solid particles of an alloy of silver, tin, copper, and sometimes zinc, palladium, indium, and selenium. Early in the 19th century, it was used as a restorative material by mixing the silver coins with the mercury. And since then till now, it is used as a part of the everyday dental practice. In the 20th century, the development of the dental amalgam was by one of the most famous dentists ever, G.V. Black. He recognized the importance of understanding the properties of amalgam and improve its performance. So amalgam is formed when mercury is mixed with other metals. Mercury is liquid at room temperature, and you can see that from these three pictures that the mercury is liquid. It will solidify at minus 39 degrees Celsius. The term dental amalgam is only used when you are referring to the material produced as a consequence of the reaction between mercury and an alloy. The alloy in the traditional dental amalgam was a mixture of silver, tin, copper, and sometimes zinc and mercury. This table shows the composition of the traditional dental amalgam. You can see that the silver has 67 to 74% of the composition, which is the highest. Then we have the tin, 25 to 28, copper, 0 to 6, zinc, 0 to 2, mercury, 0 to 3. Silver tin is the main constituent. Silver tin is known as the gamma phase. This combination can exist in different solid phases as shown in the equilibrium phase diagram. In amalgam alloy, we selectively use the gamma phase. The role of each component is as follows. Silver tin will react with mercury to form the dental amalgam. In order to increase the strength and hardness, copper is added. Zinc may be present as a result of the initial production of the alloy, but it has no role in the amalgamation. Mercury is added to give a more rapid reaction, which is referred to as pre-amalgamation. The alloy is used in the powder form, and it's available in two shapes, either late-cut particles or spherical particles. The size and the shape of the particles are critical in the handling characteristics and the final properties. Late-cut particles are produced by machining the solid ingot of the alloy in a lathe. Basically, a lathe is a machine that is used for shaping woods, metals, and other materials. After that, the chipping of the right size are chosen. Then they will be heat treated in a boiling water to reduce the reactivity caused by internal stresses. For the spherical particles, alloy ingredients are melted together and then sprayed into an inert atmosphere, where the droplets will solidify as small spherical pellets of various sizes. It has an advantage that it requires no further machining and it offers the best control over particle sizes. The mercury that is used in dental amalgams needs to be very pure, and to assure its purity, it is triple distilled. It should appear highly reflective, and if it appeared dull, it has been contaminated. The setting reaction is as follows. Silver tin, which is powder, gamma, mercury, liquid, silver tin, gamma, it is an unreacted alloy, silver mercury, gamma 1, amalgam, and tin mercury, which is the gamma 2, the matrix. From this reaction, we can get that not all the alloy particles will react with mercury, and an example is the gamma, which is silver tin. The final structure is a core of mercury held together by a matrix of gamma 1 and gamma 2. Properties of traditional amalgams. Let us talk about strength. The strength of the amalgam is extremely important, since the restoration will be able to withstand considerable loads generated during the mastication. And the final strength of the amalgam will be a function of the properties of the individual phases. So gamma and gamma 1 has similar hardness. Gamma 2 is much softer. And for the tensile strength, gamma has the highest tensile strength, which is 170. Gamma 1, 30, gamma 2, 20, and amalgam 60. The strength is affected by the particle size, shape, and condensation pressure. When there is high mercury content, the material will be weak. So, when the content of the mercury is less than 50%, the amalgam will be stronger. Spherical particle will need less force for the condensation. The excess mercury should be removed after the condensation. The second property of traditional amalgams is flow and creep. Creep is the flow caused by load acting over long periods, like the occlusal load. It depends on both the yield strength of the material and the temperature of the environment, and it only becomes a serious problem when the environmental temperature is greater than half the melting temperature of the material. Since amalgam has very low melting temperature, 80 degrees Celsius, the restoration are subjected to repeated loading. So there will be possibility of creep. And the phases that are most prone to creep are gamma 1 and gamma 2, which are mercury-based as we discussed earlier. The third property of traditional amalgams is corrosion. Amalgam corrodes, and it's often considered as an advantage because it will help to produce a good marginal seal. It is mostly associated with the gamma 2 phase. So, in the oral cavity, gamma 2 plus the oxygen will give us oxide and chloride plus mercury. But this process will weaken amalgam structure and cause breakdown of the restoration. Traditional dental amalgams suffered from a lack of strength and excessive creep and corrosion, and now it has been improved. High copper content dental amalgams. It was found that amalgam properties could be improved if their strength could be increased, and this is possible if the amount of gamma 1 and gamma 2 could be reduced, and the best is to eliminate gamma 2 entirely. An example of the high copper content dental amalgams is the dispersed phase amalgams. It was made in the 1960s in an attempt to improve the strength of the dental amalgams, mainly by increasing the copper content of the alloy. The first reaction is similar to the traditional type, and it is followed by a second reaction. Gamma 2 plus silver copper will give us copper 10 and gamma 1. So the final amalgam contained little or no gamma 2. These pictures shows the microstructure of the dispersed phase amalgams. The copper in the lathe cut is present in the form of discrete areas and remain mainly within the original alloy in its unreacted form. The copper in the spherical particle is uniformly distributed, and it is easier to alter the composition of the spherical particles. This modification in the setting reaction of the dental amalgams resulted in a higher compressive strength, a more rapid set to fall strength, a reduction in creep, and a reduced susceptibility to corrosion. Other high copper content formulations is the all spherical high copper amalgams. It has an advantage of easy condensation plus the advantages that we've mentioned in the previous slide. The powder is a ternary spherical alloy of silver, tin, and copper. The setting reaction is as follows. Silver, tin, copper plus mercury will give us silver, tin, copper, and gamma 1 plus copper 10. It can also be lathe cut, and the copper content can vary from 12 to 30%. Selection and use of dental amalgams. The factors that need to be considered are the variables under control of manufacturer and variables under control of dentists. Both of them will have a profound effect on the properties of the dental amalgams, such as the handling characteristics and their clinical performance. The variables that are under the control of the manufacturer are composition, particle size, and shape. As for the composition, high copper is better than the traditional, because as we mentioned before, the rate of the marginal breakdown is most certainly lower, and the resistance to creep has improved significantly, but so has the resistance to corrosion, and there is increase in the compressive strength. Another feature of the high copper amalgam is that they do not contain any zinc, since zinc is understood to be the source of delayed expansion when an amalgam becomes contaminated with saliva. This is an additional advantage. But one disadvantage that has been noted with some of the high copper amalgam is that their surfaces are more prone to tarnish. For the particle size and shape, fine particles are easier to condense and carve, but also take more mercury. The spherical alloy system condenses more readily than the lathe-cut alloy composition. The variables that are under the control of the dentists are proportioning of alloy and mercury, titration, condensation, carving, and polishing. Proportioning is most commonly carried out using volumetric dispensers or pre-proportioned capsules. The advantages of the pre-proportioned capsules is that the dentist doesn't have to worry about the ratio because it is prefixed by the manufacturer. Plus, it has less danger of mercury spillage during the handling stages. The lower mercury content is the final goal, so a good condensation technique is required. Titration is one of the most important variables. Mechanical is more efficient than the hand titration. If amalgam is found to set too rapidly, then go for more titration time. Ideally, it should expand slightly on setting to ensure marginal adaptation. The main objectives in condensation is to remove as much excess mercury as possible, to have no porosity in the restoration, and to achieve optimum marginal adaptation. Lastly, carving and polishing. The ability to carve an amalgam is a function of the size and shape of alloy particles, and the spherical particles offer a better initial surface finish. Since the introduction of the composite resins and the glass ionomer cement, there had been some limitation of dental amalgams, such as poor aesthetic, mercury toxicity, and this can arise from accidental spill or during the removal of an old restoration. High thermal conductivity, and this is expected since it's a metal, and the dental amalgams has very high thermal conductivity, which may irritate the pulp. Galvanic effect. This effect arises when two metals contact and they have different electronegativity. In the dental case, this medium is the saliva. Lack of adhesion. That's why you need to do specific cavity with a specific depth. Lack of strength and toughness. It is very brittle and limited lifespan. The main source of mercury exposure arises from the accidental spills, poor mercury hygiene, direct contact with mercury, amalgamator, placement of a new and removal of old restoration. The most serious potential hazard is from mercury vapor, and the most significant source of this vapor is spillage of the mercury. The use of amalgam capsules should minimize this risk. The threshold for air mercury exposure hazard for the general population is 50 microgram per cubic meter of air. The signs of mercury poisoning include leg cramps, itching, rashes, excessive perspiration, rapid heartbeat, intermittent low-grade fevers, irritability, marked personality change, insomnia, headaches, hypertension, chronic fatigue, and nerve dysfunction. It is very important to follow the appropriate mercury hygiene procedures, and these include the use of a no-touch technique, the use of mechanical amalgamator with good seals, the storage of mercury and old amalgams under water in unbreakable, tightly sealed containers, cleaning up of spilled mercury immediately. Ideally, the amalgam alloy of choice should show little or no creep and should have a high corrosion resistance. Lab and clinical evidence suggested that an admixed zinc-containing high copper amalgam offered the most satisfactory restoration. Amalgams have good record of successful performance and they are simpler than the other alternative ways and they will continue to be useful for posterior teeth. And as for composites, they are very good, but they require care and time.